Welcome to all. This is part 5 of analysis of singly and WA in post sections by working test method for people in general. Whereas for the RCC group, this is class number 18C, concluding part of singly in post section for you. I think class number 19 already conducted for you. Okay. Then I left one more gap there. That I will go for WA in post section, and here general public I will write part 6, 7 like that. Okay. Now, just an information for, this is only for those who are studying from me the basic RCC course. See, we are almost finishing working test method. Practically at present it does not require much, does not have that much important. Of course, I told for serviceability you require it, and for basic understanding you require, because you start by limit state method. Another 3 or 4 days we are starting limit state method. That is, actually our course will actually start after 3-4 days for those who are interested in design oriented class. Now, so but remember, these concepts you will not get once again. So before I start limit state method, you go through all these classes, thoroughly understand. Today's class also important class. See, I will tell you first. I wrote class here. Means something I am telling in the class. Roman 1 was for finding stresses developed for given bending moment. I told you, apply a bending moment, you find how much stress will come. We are not bothered about permissible limit, safety, etc. We are not bothered. We solved 2 main questions. Then, Roman 2 is for finding MR. There are also 2 questions over, one for under reinforced, one for over reinforced. Now, today's class, see, Roman 2C. By seeing Roman 2C, you should tell this question is for finding what? Roman 2 is there. So this question is to find MR. Already over, one under reinforced, one over reinforced. Why extra? Yes, 2 more extra. But remember, only brief solution. Roman 2C is almost same as Roman 2A. It will come under reinforced. Next time, one more. Roman 2D will be same as Roman 2B, which will come over reinforced. But important is not that one. So therefore, first I will dictate the question. Dictate the question right here. Question, Roman 2C, continuation of MR calculation. Find moment of resistance of a rectangle. You should write, because question I am not writing. Find moment of resistance of a rectangular section 300 by 600. I think it is visible. By chance, due to any recording problem, not visible. I am telling now, this is 600. 300 millimeter by 600 millimeter. Subjected to sagging VM. So therefore, I told you, top compression, bottom tension. Leave it. Further, tension side, 3 bars of 60 mm diameter are provided at effective cover of 50 millimeter. Then, if you observe correctly, someone will tell, sir, this is same question as Roman 1A, where you told bending moment of 60 kilonewton meter, 60, yes, and asked us to find stresses developed. Yes. At that time, this question was for finding stresses. Now, same cross section, I am taking for MR. So, don't see those things. Therefore, that time, I told you only modular ratio value, why you require. I never bother to tell what is the grade of steel or what is the capacity of concrete. Not required. Why? Apply the bending moment, stress will come. Okay. But this time, it is MR question. So, question continued. I told just now, find moment of resistance, then taking M25 concrete and FE 415 steel. So this time I have to give grade of concrete and grade of steel. Okay. Now, see, briefly, B, brief solution. B, D. You have to calculate. Why? Wherever waves are there, because if I explain further now, it is an offense actually. Why? Then you are not doing anything. B, D, AST, concrete 25. As per IS code, sigma CBC 8.5, steel tar, FP415 230. Required to find MR. Okay. Now, continue. Brief solution, something in the class. Correctly follow the procedure for MR. X you require. You require M. M you have to calculate. How you to calculate? Already told, you calculate, M will come 10.98, X will come 135.314. Actually same X came there also. Now you to MR class, you require maximum permissible stresses, not incomplete, compressive stress for concrete and stress in tension steel for given cross section. Right? You get K, find XC. Compare X with XC. You can see here under reinforced came. Now class. Class is not telling anything. Go back to earlier class, refer what I told for under reinforced section, or go to first part where I thoroughly explained procedure, understand, come back and get FST max permissible. See, under reinforced section, I will again tell stress in steel will reach the critical first 230. See here, stress in steel 230. But at that time, stress in concrete will be less than sigma CBC. It won't reach 8.5. Now, therefore, you can find MR by tension equation. Find MR, you get 70.046 kilonewton meter. Or if you want to find MR based on compression, find max permissible FCBC. How means don't ask me. Correctly get it. I already told how to get it. Corresponding to FST equal to sigma ST using that equation MFCBC by FST equal to X by D minus X. Get FCBC permissible 6.855. MR will come same. Or one important note you make before going further. For this cross section, if you want to find the MR, this is the under reinforced section. Stress in steel, tension steel will reach critical limit of 230, and at that time stress in concrete will be 6.855. So steel will reach critical, concrete will be relaxed, it will be less than 8.5. Okay. Question 2C over. Class. Now continue something else. Okay. You make a fair copy of this one. Put one solid line. Then write. Again class. What I am telling right here. Refer to part 2 where Roman 1, I will tell you, Roman 1A and Roman 1B are given. At that time, I told what is the bending moment. See, no MR. How much stress will come? Everything explained. Now, actually, this cross section is same as Roman 1A, and the question which is coming up, which is Roman 1B, only change is earlier we had one stress calculation. So just a reminder. Now this is a reminder. This full reminder. So Roman 1A long back we solved. Refer part 2. You can tell this question we solved under Roman 1A where bending moment given. How much given? 60 kilonewton meter. First I given 60. Okay. Find stresses developed. Okay. Solve. How to solve? Already told. See there. For 60 kN meter, stress in concrete, instead of wasting time in maximum compressive stress in concrete means, if I tell stress in concrete means extreme fiber compression, stress in steel means tension steel. See, it will be 5.855 and 197.013. This we got in the class. Now write a comment. Oh, means a BM of 60 will result in stresses in both concrete and steel less than their permissible limits of 8.5 and 230. So you can tell 60 BM is safe for the cross section. It is like you have 200, see, suppose you have 258 rupees, odd number, Somebody will ask you, how 258? You have 258 rupees in your pocket. The bill came around 200 rupees. Oh, safe. Over. Now, then, right, I told for same question at that time, I changed the BM to 70, 70.046, 86, 87.107 and 90. Solve. I hope you solved it. If you are not solved, kept quiet, you are not interested in learning what I can do. So this is for those who solved it. Now, okay, change. When BM changed to 70, this all, see, this everything is old result. Old result for Roman 1A. When the BM increased to 70, concrete stress reached 6.831, steel reached 229.849. Oh, you can tell. Concrete stress is still much less than limit. Why? Limit is 8.5. Concrete limit is 8.5, but steel is very much reaching the limit, 229.849. It is approaching. Like if you have 258 rupees, bill came 256 rupees. Oh, you can tell. Oh, what is this? My almost entire money is gone. Little remaining. Okay. Then I told 70.046. Somebody will ask, sir, why you gave such odd value? Now you know why I gave odd value. That time I calculated MR and that BM I given. Now observe, for 70.046, stress in concrete became 6.835. See here, 6.835. Huh? Why it is 855 then? 1 minute, I'll check the sheet. I'll check the paper. 6.835 it is. Okay, 835 only. 835. That is 835. Okay. Print mistake. 6.835. Steel reached exactly 230. Or a BM of 70.046 results in stress in tension steel exactly equal to limit. That means you cannot increase BM further. If you increase BM further, it is unsafe in steel. So that's why unknowingly 70.046 is actually MR. See the answer? Over. Now just continue. Increase the BM to 86. You are so sure that stress in steel will go beyond the limit. It will go to 282.386, which is more than 230. Concrete will increase to 8.392. Now you can see both stress will increase. Now concrete also reaches coming near to limit 8.5. Then further increase 87.107. This I have given for this answer. A particular BM will give stress in concrete equal to 8.5 limit. But it is not MR because for that BM, steel stress will go much beyond the limit. Okay, now lastly 90 I told, where concrete and steel both stresses are beyond the limit. What you can do? If you have 258 rupees with you, if you eat for 400 rupees, he will not do anything. He will tell, give 400. I have 258 rupees. That you should have thought before eating. Now helpless, pay 400 or he will tell, I will take care of you. So therefore, that is randomly applied BM. So that's all. Now go through all the statement, understand. Further I not required. See, I told you to get FCBC, you got equation for M. Where I wrote it? Somewhere I wrote it. FCBC, maximum compressive stress dot in concrete, FS each way. Or I will write here. See, this if you use based on compression, M equal to BX FCBC by 2 into D minus X by 3. Here M is the bending moment, FCBC is the stress developed. Or here I wrote here, there I forgot to write. Here you can use M equal to ASTF at D minus X by 3. M is the bending moment, not MR. Or you can do one thing, use this equation, get FCBC, use the connecting equation, get FST. Or use this equation, get FST, use connecting equation, get FCBC. Your choice. Now you understand correctly as the BM increases how the stresses will change. So we applied a BM per 60. It's a safe BM. At one particular time, we reached the MR. Then up to 70 is safe. Even 70.02 is safe. 70.046 is critical. That is MR. What happens if you further? First, what happened? Steel reached critical. After some time, steel went beyond limit. Then finally, concrete becomes critical. Then both of them go beyond the limit. Okay. Now, what I will do is, this much explanation I will not give for next question. That is Roman 2, here, Roman 2D. I will tell now only. It will come over reinforced here. Okay, then already you know the principle. I will write everything here so that those who are serious can solve over reinforced over. Here what will happen is, reverse will take place. As you increase the bending moment, over reinforced, too much of steel. First, concrete will reach critical. Not 8.5 because that question some other concrete. Concrete reaches critical. Then after some time, concrete becomes much more than critical. Steel will reach critical. Then both will go beyond the critical. That much sufficient. What I will do is, I will take the eraser now, rub and change the numerical, and then briefly explain once again after I fill up the board. Okay. After I fill up the board, I will explain once again. We will continue. I changed the board. See, actually second question, I given hogging BM earlier, if you remember. So top will be tension, bottom will be compression. So these all I have to change it. I changed everything. See, last time I wrote FST this side, FCBC that side. Now I wrote FST that side, FCBC this side. Last time D was from top edge. Now D is from bottom edge. This all told for you. So during this change, by chance, if any old value is still there and if it is wrong, just ignore it. Don't make an issue of it. You tell this is the same as last time. By mistake. Anyway, when I explain, I can go through. Start. Roman 2D. Remember, now you are in Roman 2. One more homework for you for MR calculation. Question dictated. Rectangular section of a RC beam 230 mm by 500 mm is reinforced on tension side by 2 bars of 20 mm diameter at a clear cover of 40 mm. Remember, BM is hogging, so consider hogging BM. Okay. Therefore, tension at the top, 40 from clear cover here, extreme compression edge, D and X from this side. Okay. Then, question continued. Taking M20 concrete, already explained, and tar of grade FP 500, this is all known to you. Find moment of resistance of the cross section. Over. Start. You require M. Now M will come 13.33. Calculate X. You want permissible stresses because MR calculation. K and XC. Compare. X will come more than XC. Over reinforced. So, wherever class is there, same as last time. So, over reinforced section, concrete critical, stress in concrete will reach 7. That you can make out later. Critical. At that time, stress in steel will be less than the limit of sigma ST. Or use the equation, connect FCBC FST. When concrete reaches 7, see how much stress will come in steel. 1:10, money matter for those who are in the group. It will come 189.932. Either use compression equation or use tension equation. MR will come this much. Okay. This is full homework. Why? Already over. Okay. Now, question 2. Question 2D over. Someone will tell. Those who want to find mistake. It was C. Now D. He forgot to change. Okay. Class all safe. Now, come here. Again, class. Something I told last time. Make a note. Same cross section, long back. In Roman 1, we considered a question. But at that time, we are not knowing what is MR. Permissible stress we are not knowing. Eat something, pay for it. That time I told, same section. But that time I wrote 2 of 20 mm diameter. Why? Tar I have not written. Because why? It can be mild steel. But MR question, see, I wrote tar. It is given. That time, tar, mild, etc. not given. whether 415, whether 500 not given. Now, as usual, tension top, compression bottom for a bending moment of 40. See, this time, if you remember, I have given the value, I forgot to tell. Last time question for this one, I told you, right? See the question there. I told M equal 10.98. That is same as that number. This question earlier in the stress part, Roman 1, I told M equal to 13.33. Okay, start. First I told find the stresses in concrete and steel. I won't waste time telling maximum, etc. Understood. For a BM of 40 kN hogging. Okay. This answer you got. See, now, you know that if you use M20 concrete, you write here. If suppose for this one, suppose they give data, it is M20 concrete, FP 500 steel, then MR is 47.805. This bending moment is 40. It is less than MR. That is, you are eating something less than the money you have got. In the pocket you have got, how much I told last time? Okay, 258 rupees. Your bill came only 220 rupees. Safe. Okay. See, both are lesser. Then I gave a bending moment of 47.5. Concrete stress jumped to, see, I forgot to change the, I think I have to change the values here. See, what happened is, I changed this side, that side I not changed. I change it now. Okay. I'll change it. 188 point. See, everything over. Only thing is, forgot to change the numbers here. 6.9. Okay, no problem. Not an issue. This is 189 point. This is gone. 189 point. Okay. 932. Those people who want to unnecessarily find mistake. Okay. This is gone. 188.723. Okay, little time wasted. Okay. This is exactly 7. Okay. 7 I'm underlining. Then this will be 274.141. This is 10.104. Everything I wrote, but by mistake, forgot to change, interchange it. Okay. Then when I give 69.2162, this is 275. Underline. This is 10 point. This answer already known to you. I have given this table earlier for you. This I given earlier as a homework. 10.25. Line is slightly lost. Okay, not an issue. 278.114. This is cancelled. This is cancelled. Okay. Now correct? Okay. This everything okay. See, sometimes what happens is people forget something. This is not technical mistake. Slowly I will take classes where people make technical mistake, where they make blunders. I want to educate them, not insult them, educate them. It will start soon. Don't make the mistake. Number one mistake people make, telling bending moment shear force are internal. I will outrightly prove they are wrong. It is external. They are not internal. Time will come when I prove it. All the people who 99% people are telling shear force and bending moment are internal. I will outrightly prove that is external. It can't be internal. Let them come in front of me. Start arguing with me. Within 2 minutes they will tell, sorry. Okay, start. Now, I told BM of 40 stresses came. See now, both the stresses are within their limit. Tell why? Because this bending moment is less than MR. Now you understand. Then I told 47.5. At that time, see, it is very near to MR. Since it is over reinforced section, 47.5. See, concrete reaches, goes very near to its limit of 7. Still not reached. Like 258 rupees you have got. Bill came 256 rupees. Abba, safe. But marginally safe. But steel is still relaxing. See, 189. Why? Limit is 275. Then I gave a bending moment of 47.805 because at that time I calculated MR. But for you it is given. See here, concrete reached exactly 7. See, 7. And at that time, steel reached 189.932. Oh, now you can tell, yes, surely this BM is MR. Because if you increase the BM further, steel okay, why 189, it has to go 275, but concrete will go above 7. It is unsafe. Okay, now I increase to 69. See, concrete from 7 jump to 10.104. It is not safe, but at that time you are not bothered. But steel now reaches critical 274.141. Little more BM I given. Steel reached critical, but concrete gone much beyond the limit. Section is already unsafe. The moment you exceed this bending moment, it is already unsafe. Now finally, I gave 70, where steel and concrete both gone beyond the limit. See there, over reinforced section, concrete gone beyond the limit by a huge margin, but steel went beyond the limit by a small margin. Like if you have 258 rupees, if it is a concrete, bill came 400 rupees. Oh, yo, gone case. But if you have 258 rupees, if it is steel, bill came 260 rupees, 2 rupees more. Maybe if you request, he may allow. Okay, now over. Now, everything explained. Go through this question, all this. See, to understand the second part of the question, you have to go back to your class number 2, and what I told homework there, you have to work out. Then only it will be clear. If you simply see what is going on, it is suppose someone who is not seeing all the classes, he may tell, hey, this person keeps on telling something, we don't know what is going on. Don't see the class. Everything, part 1, part 2, part 3, part 4, in order. Take a book, write everything systematically, pause wherever you want, write all the statements, make a pakka fair copy. Over. Now, today is part 5 over now. Now, next class will be class number, I think 20 for my regular group. Okay. You don't bother. Others, I will tell in the group there. For you, it is part 6. I am starting doubly reinforced section. There will be 3 or 4 classes. Why? Or 3 classes will be there. One class. One class is full basic concept or equation. Second class, how to find stresses due to a given BM. Third class, how to find moment of resistance. There I will do double question, once under reinforced, once over reinforced. Remember, one problem in WA reinforced, I told you, singly reinforced, you get expression for M in terms of compression and also tension. WA reinforced, expression for M in terms of compression is there. In terms of tension, some will tell it is not there. No, it is there. And that, how it is there, I will take extra class information. But I will advise everybody, don't do it. Only for those people who want concept. Someone told me earlier, in tension doubly, equation is not there. I told what not there. If MR is there, if bending moment is applied, there is an equation. I will get it in the class and show that answer will come same. But unwanted, it is like instead of eating this way, eating all around this way, don't do it. So that I will tell you later. So next will be class, not class 6. Sometime it will be class 6, it is part 6. Part 6 for you, where WA post, I will start. Okay. Now, if you want to correctly understand everything, go through everything. By chance, if there is any mistake in writing, like rubbing and rewriting, is there, see, just now something happened. Ignore it. You ignore it. Don't make an issue of that one. You make technical point issue, not writing mistake or spelling mistake, etc. Okay. See you in the next class. That is part number 6 for in general.